Okay, so last time, as a augmented reality between what we did in class and then the videos I provided you, we had our homework assignment on adding the counting the number of numbers between 1 and 1 million that were evenly divisible by a bunch of stuff, right? Okay, well we'll look at the solution of that here in a little while. Let me just finish some of this prerequisite stuff here. Because I believe the videos I gave you did not cover the web languages. Is that an accurate statement? I kind of flipped through them earlier tonight just to see what was in there. So sometimes I do the web and native languages in different order. So let's talk about the web languages then. So I believe they finished the discussion, though, of the Java versus C#, all that jazz, right? And then they probably got into did it do variable sizes, like the size of an int and byte and short size? No. Okay. All right. So we'll segue into that. Okay. So let's go this route. Let's add them to our picture first. So let's just finish fleshing out this picture real quick since you've already seen it, just to bring ours up to date since we don't have some of the slides in here that were in the other one. So I'll toss down here Swift. Now, more than likely in the video I introduced Swift, but said it was going to be like a secret, like I wouldn't tell you where it came from yet. Is that accurate? Okay, good. So you'll get the punchline after we talk about the web stuff. And then if we kind of throw over on this side of things, this is Objective-C, which is, let's call it the Apple language. So quick punchline here so we can get into the programming stuff is when we made that move from C to C++ in the object-oriented side of things, Microsoft jumped on the C++ ship. Apple wasn't going to follow Microsoft, so they backed another project called Objective-C. They're both object-oriented versions of, let's say, C. The one difference is I kind of advertised, and I may have said it in the videos, but it's worth saying again here. I've kind of advertised that all of these languages we're talking about are all derived from C. So if you were to look at C# code, it's going to look a lot like C. Now, that is a true statement, but at a glance, when you look at a programming language, if there's such thing as an intimidating looking programming language, Objective-C is probably that. And it's not because it's actually difficult. I mean, once you get into Objective-C and start, working with it, you recognize the fact that it's the same as all the other ones. It just looks a little bit different. And let me just give you a quick example. Like I said, I may have done it in the video, but maybe I'll use a different example here. Did I give you an example of Objective-C in the video? Okay, good. So for instance, when we write system.out, when we write hello world in, let me just do hello so it's shorter. When we write hello to the screen in Java, it looks something like that, right? We all last week, and I'll get caught up on those assignments, by the way. Last week was a rough one. So, but when you did your assignment on the Hello World program, we all saw this line, right? So system.out.println hello, that's what makes hello show up on the screen. That's Java. Let me show you the equivalent line of code, and we'll just do a couple other languages, just so we have some reference. So let's look at it in C. So this would be printf hello. Let's just do \n there. So that's C. So this guy up here is Java. This guy is C. C++ would be C out. Printf would actually work in C++, but cool kids would write it that way. So that's C++. Console.writeLine. Come on. That's C#. All right, so you know, these guys in the middle here look a little funky, especially the C++. We took a little weird turn here. C++ had a library that was introduced called IOStream. That's what this guy comes from, but you could still do the printf stuff. So minus this little funky stuff here, we would say that the other three look pretty similar, right? Within reason, they're in the right ballpark. Well, let me show you, I'm going to write the syntax. This actually isn't the exact way you would do it in Objective-C, but I'm going to write like the Java syntax Objective-Ciified. Okay, so system.out.println in Objective-C would look like this. So we're going to call that Objective-C. So the big issue here is that you're using this square bracket notation instead of the dot notation that we see everywhere else. Well, this kind of predates object-oriented, so we didn't have the dot there. But dot notation is kind of the commonality among, let's call it, pretty much all the languages I'm going to talk about today, except Objective-C. Objective-C took a different course, and it's not like right or wrong. So this dot notation is one approach. The opposite approach is something called message passing. So this guy right here, we are sending the system object a message. What message? That message. What message is that? Well, it's the message produced by sending the out object this message. What message is that? It's the message to call your println method with this single input. All right, so it's ultimately saying the exact same thing, just the syntax looks a little funky, right? So once you get into Objective-C and you get past that stuff, everything ends up being peachy, but understand that that is a difference between them. All right, so I'll shrink this down and leave it over on the right-hand side in case you want to reference it, so it's not in our way. Okay, but an issue here is, I probably gave you the precursor in the videos when we were talking about Swift, is Objective-C. Well, so Swift is our most modern language, right? I think this is like 2014 or something like that when this dude came out. And really, it was probably in practice around 2015. So significantly more modern than these other guys. Java was around 98, 99. So let's go 98. C# was in the 2000 ballpark. So anyway you cut it, we're looking at about a language that's 15 years newer with Swift. Okay, give or take a couple of years, because I'm guesstimating some of these dates. But with that in mind, we would expect Swift to be far, far superior to all these other ones. There's got to be a reason for it. And kind of a common misconception, and it's actually something Apple would have you believe, is that Swift is the upgrade to Objective-C, because this is all on the Mac side of things. So if nobody on Windows uses Swift, even though they do have a Swift interpreter for Windows. Nobody writes Swift code for Windows. It's all on for iOS and Apple, Macintosh software. But mostly it's for writing stuff for iPhone and iPad when you would use this stuff. So with that in mind, it's a common misconception to think that Swift is the upgrade to Objective-C, because Objective-C is so old. It's back from the early 80s. It must need to be replaced, blah, blah, blah. The reality is if you're already drinking the Apple Kool-Aid, okay, you're already an Objective-C programmer, you're not complaining. In fact, I write a lot of iOS software. I use Swift for all the software because that's what everybody does today. I prefer Objective-C. I think it's the better language. And that'll make sense here in a few minutes once I tell you why Swift exists. All right, but I promise you, Swift, Apple was not motivated to come out with Swift because these guys were screaming so much. All right, now there was a period of time before, so let's say 10 years ago or so, before iPhone came out, when the only people who were writing stuff in Objective-C were people writing software specifically for the Mac, right? But then So that was a relatively small population, right? You know, I have this slide I usually create called the Big Three. I don't know if it was in the video. Ooh, the Big Three. Was that in the video? Okay. So Big Three. These are what I call the three big native languages. Okay, and these guys would be Java, C#, and Objective-C, but now that's been replaced with Swift, let's say. All right, and this comes down to right tool for the job. This is Windows crap. This is Apple crap, so whether you're doing Mac or iOS stuff. And this is both, platform independent. Okay, I want to write software that'll run on everything. All right, so you can say both, runs on everything.
Okay, you mentioned that you just said that's for all other stuff.
Yep. So this is why these guys are around today. You know, I can make the argument that Java in many ways has not programmatic weaknesses, but technology weaknesses to the other ones, just because of the nature of that virtual machine. I mean, you got performance issues already that you know have been discussed. Because of the virtual machine, it's being interpreted. The tools itself. If you when you were doing your Hello World assignment, some of you probably ended up stumbling upon. So I'm guessing there was 3 different approaches for the Hello World assignment. Some of you did the kind of the traditional Java thing where you use Notepad or something like that to write your Hello World program. You compiled it from the command line, javax space, whatever it was called, .java, then java space, the name of the file, right? And that ran it. How many of you did that? The traditional, not using any special tools thing. I thought you did. Didn't you ask me the question? Oh, you did. You did multiple things. Okay. Okay. How many of you used Eclipse? Probably many of you used Eclipse. How many of you used NetBeans? Oh, no NetBeans people. Okay, interesting. So Eclipse and NetBeans, these are things called IDEs, Integrated Development Environments. Think of them like word processors for coders. Okay, so it's just like Microsoft Word, except instead of being focused on writing term papers and stuff, it's, you know, helps you write computer programs. You know, does command completion and crap like that. That's what they are. Well, the makers of Java, which used to be Sun Microsystems, and now that was purchased by Oracle, so now it's Oracle, they have a product called NetBeans, which is a IDE for writing Java crap. And it's popular enough, but really the industry standard for writing Java stuff has kind of become Eclipse, which was an IBM product. Now, the punchline there is that when you look at one of those tools, they only really incorporate either the main Java product, which is the Java Software Development Kit, Java SDK, or maybe 1 or 2 additional Java technologies. But if you go to the Java website, you'll see there's like 25 or 30 technologies over on the right that are all Java related. Now, the issue is there isn't the single product that's like a one unit that has everything integrated into it. If you want to do Java servlet kind of stuff, you have to go and get a servlet container software. Like there's a product called Tomcat Jakarta is one of those. And you get that installed and you put the Java plugin for that. And you have to get your whole development environment all set up before you can even start doing your stuff, rather than just popping open an IDE and going to town. Okay, so it's Java never really pulled their stuff together, right? Everything is, you know, we have a lot of really cool, interesting tech sitting out there related to Java, but it never got pulled together into a single product. That's actually something Microsoft has done a really, really good job of. Okay, so on Microsoft's side, you know, this is their product is called Visual Studio. So Visual Studio is Microsoft's Eclipse, okay? But Visual Studio is extremely integrated. It has all of the .NET languages built into it. It has your, you know, build a graphic user interface tool built into it. It has the ability to integrate with Microsoft's cloud, Azure, built into it. It has the ability to integrate with Microsoft's database, SQL Server, built into it. So as long as you're sticking with Microsoft products, everything is in one place. It has collaboration between developers built into it. So you don't have to leave the IDE in order to, if you're working on a project with 5 other developers, You don't even have to leave the single piece of software to have like an ongoing chat or real-time bug fixes and stuff like that. It's an extremely well done and integrated product. Okay, and it's been one of the big reasons why maybe we can say the .NET languages have been so successful. Probably the biggest reason they've been so successful is here that they're built for doing Windows crap. Okay, and Microsoft has a extreme lead in desktop operating systems. Apple has made a big comeback in recent years. They're probably up to about 5 or 6% of the market share, where Microsoft is well clear of 90%. You know, they used to be like 98%. Now maybe they're 93 or 94 or whatever it is. You know, a lot high. It's very high, the percent that they're sitting at. But Microsoft did a very good job of integrating that. Now, Objective-C, Apple's version of this, they have a tool called Xcode. Xcode is their Visual Studio. Now, I would say that Xcode does as good of a job as Visual Studio does of integrating all the tech. But there's one, let's call it weakness there, and that's Apple doesn't have as much development tech as Microsoft does. So Apple, Xcode does a great job of integrating your, writing your software and building your interface all into one thing. Okay? But Apple does not have a cloud, so they don't have the Microsoft Azure cloud thingy. So you got to use somebody else's cloud. You can use Microsoft Azure, you can use Google App Engine or Google Firebase. Or for a while I used a product called Parse, but they got bought by Facebook and then got shut down. So weird, but in any case, Apple doesn't have that to leverage. Similarly, Apple doesn't have a database, so they don't have that to leverage. So what they have built in and have integrated well. All right. But at the end of the day, if I'm writing iPhone software, I'm on the Mac side using Xcode. That's the correct tool to do that. If I'm writing Windows software, or let's call it Windows Mobile, nobody writes Windows Mobile software, but let's assume you were, you'd be in Visual Studio, running Windows, running Visual Studio, writing .NET stuff. Okay, if I'm writing some utility that I want to run on multiple platforms, I'm going to be writing Java. And then I can pick my poison if I want to be on the Mac side or the PC side. Now, maybe the biggest thing that's really kept Java relevant today is Android. All Android software is written in Java. Okay, and we can actually, extend this and really say that a big reason for Java's success is Google. Google was a Java shop. That was their core language. Really, it was Java and Python were kind of the two go-to languages in Google. And we'll talk about Python here in a few minutes. And part of that was because, one of Google's main competitors was Microsoft, right? Now, Google wouldn't necessarily come out and admit, hey, we hate Microsoft. It doesn't have to be a like-hate relationship. They're a competitor. And you don't want to be reliant on your competitors' technologies for your success. I mean, it's just good business, right? So, obviously it would be difficult for Google to adopt Microsoft technologies internally. What would keep Microsoft from just haphazardly changing their product in order to break Google stuff, right? So Google kind of got on the bandwagon with the Java folks, and they kind of kept riding that right into Android. Google's also the makers of Android. All right, so, interesting thing, I guess. So these are what I call the big three. That's totally a Littman thing. You're not going to find that in any textbook. All right.
I have a question. At the time of the transition, wasn't Java also once Apple?
Oh, okay. Well, Apple did adopt Java for a while. Yeah. So in fact, I think some of the early versions of OS X had Java built into it. They quickly moved away from that. So they did have Cocoa libraries written in Java, but Sun Microsystems went the same route with Solaris. They had Java built into the Solaris operating system, and there's some major weaknesses with that from the perspective of performance. But yeah, basically you had Apple and probably for a very similar reason. The Apple, if the Apple wanted to bring newer technologies in, other than this archaic but working technology from the early 80s, who are they going to look towards? Well, they can't look at C#. I think it's fair to say Apple did hate Microsoft. Okay, that had to be the hardest press conference ever for Steve Jobs to have Bill Gates on the big thing saying that Microsoft Office is coming to the Mac. It was a necessity, but man, your number one enemy and you have to rely on them. Steve Jobs, when Steve Jobs came back to Apple and Apple needed to be saved, they couldn't make their pay their payroll and stuff like that. Microsoft helped bail them out too. There was dollars that flowed in from Bill Gates. That's a tough pill to swallow. So it's interesting. But by that time, I think it was more of a mercy move, and maybe Microsoft saw the opportunity to get their software on the Mac moving forward, because clearly Microsoft had won the OS battle at that point in time. It would be very difficult for them to ever lose that, But they had such a huge lead. It wasn't even close. So everybody saw the writing on the wall, and Microsoft was so focused on software where Apple dabbled in hardware and software. So I think Microsoft maybe looked at Apple as less of a competitor at that point. And maybe more of a, hey, it's, what do you keep your friends close, keep your enemies closer, something, something like that. Who knows? We might be reading too much into it, but it's probably not horrifically far from the truth, unfortunately. All right. But anyways, just to finish up this conversation here, the issue here is that when Apple came out with Swift, it wasn't because these people were complaining. Very, very clearly, if you're drinking the Apple Kool-Aid, you're fine with Objective-C. The people that when iOS came out, and people came over from the C++, C#, Java world to learn Objective-C, it had nothing to do with any sort of love for Apple. Okay, what do you think it had to do with? Love of money, right? Okay, you got this brand new iPhone, ridiculously successful, has the only app store around, everybody's making zillions of dollars, let's go learn Objective-C. That's it, right? Okay. Who cares? Money spends the same regardless of who it came from. So you have tons and tons of people who write software for iPhone who are just Apple haters. There's actually maybe even a downside for Apple. I mentioned that Apple's Xcode is a pretty good tool, and towards the end of this course, we'll probably see some Android stuff, and the entire next class, the 537, is all Android. So I encourage you guys to keep going with it. You'll get a pretty good experience in the stuff. And my assignments do get kind of big and hard and stuff like that. But I think the punchline would be that as long as you work hard, you put in the effort, you ask questions, you'll get through the class. All right. So just don't just blow it off. As long as you put in the effort, I'm not going to fail you. And I realize that means that you kind of need that B-ish thing, right? Not my first rodeo. So if you promise that you'll work hard, I'll promise I'll grade your stuff through the correct lens that many of you aren't going to become professional programmers. You're going to be IT professionals who need to have a competency in programming, and part of that comes to being exposed to a lot of programming. But it might not be your cup of tea, but maybe it is. Maybe you become that person at the office who's the programming person. You'd much rather be sitting in the office writing some code rather than going and, crawling under some floorboards, swapping out a switch. Right? I certainly would, because I don't fit under the floorboards. But I can reach high things. So I'm the guy that goes up to the shelves. I always warn my wife, whenever she puts things low on the floor, that's her job to get those. So she keeps my soda, like to replenish it in the fridge. She keeps it on the floor, like really low. I can't get to those. Okay? But I can get to the high stuff. But when I put my stuff up high, she complains because then you can see it and it looks ugly, she says. Or if she can, with the floor, she could tuck it under stuff and you can't see it. It's not ugly. All right, so let's look at our web languages then. so we can come back to the Swift punchline, because I've already told you nobody was complaining. Okay, once these dudes jumped over here from Java and C# to learn Objective-C, they already took their medicine and learned a language that was a little bit intimidating at first. And I was one of those people. I mean, so I didn't know Objective-C 10 years ago. That was when the App Store went live. I came over. I was an early adopter of the App Store, so I had 3 apps on the store the day it went live. But I came over just like anybody else. And learned it. And at first it was intimidating, but once you get into it, I would say Objective-C might be my favorite language out of all languages. It's kind of like, like a fine wine. As you start using, I kind of like the feel of this. You like kind of finishing your lines with the square bracket. I don't know, it just feels better than a semicolon. Swift is even worse. They took away the semicolon. It doesn't even feel like the line's done. Like, what am I supposed to? I can't go on to the next line. I gotta hit something before I get. It's terrible. You should see the days where I have to teach. In one day, I might be teaching 3 or 4 different languages. I have to move into the different mode in that language, but significantly easier than I would assume speaking different natural languages. I speak English and then enough Spanish to order at Taco Bell. That's the extent of it. So, I mean, but many of you speak multiple languages. And, when you're speaking to your buddies, you just flip between language, right? No big deal. Well, programming is the same thing for me. But sometimes you'll start throwing in a couple of English words because you get too used to using English, right? I've seen you when you're sitting there talking to your buddies and you're just, going about things in Telugu or something, and all of a sudden you're just dropping English words in there left and right. It's like cheating. That's what it is. It's cheating. I know when I speak Urdu to my friends, I make sure I keep with the formal language. I never break stride. It's just Urdu all the way. It's a real language. I don't speak Urdu. I think I speak Urdu. All right, so let's throw some other languages up here. So I usually label these guys over here as our native languages. All right. That is, their target is native operating system, Windows, Mac, our cell phones. So, iOS, Android, Windows Mobile, they're built for that native experience, running actually on the CPU and that kind of stuff. These guys over here, we're going to call our web languages. Okay. And these guys they're not less important. All right. They're just different. Okay, and I think I did not cover the web languages in the video. Is that correct?
No, the slide was there, but you never.
Right, yeah. As I was flipping through, like I said, sometimes I do this side first, and then I do this side over here. And when I was flipping through, I saw my picture, and I saw this side was empty. Actually, I'll just write them all out first, so you have the list, because this one goes a little bit quicker, because one thing we run into with web is about every 15 or 20 minutes, somebody comes out with a new language, a new technology. You just can't keep up. So what I've done is I've picked some milestones over the years, and I'm going to kind of compare and contrast these, and I think you'll see that they're all the same. And that goes across the board. If you can, you could pretty much take any technology and say it's one of these 5 things. It's one of these 5 problems that technology is solving. Okay, and once you know which problem it's solving, then you just kind of pick the best of the bunch for solving that particular thing, given the problem you're currently solving. So we'll say PHP. Then we'll say Ruby. Then we'll say Python. Then we'll say Node.js. And then I'm just going to put as a floater out here, JavaScript. So that's JavaScript, JS. Now, before I get too far into this, I do want to talk about, let's go down here, go here, go here, here. Good enough. Oh, we're butchering this. do client server. When I say something is client server, what does that mean? Tell me what you know about that. While I text him telling him you stole my soda. So what's client server?
Client is a user, and server is a system that connects all the computers.
Okay, yeah, fair enough. So the general model for client server is, the server serves stuff to us, to the client. In many cases, the user is the client. Okay, so when we go into McDonald's, we're the client and we get in line and we talk to the server, place our order, and the server gives us food, right? So the client server model exists throughout computing, both on the networking side as well as the programming side. So let's draw a picture of this. So we have the client and we have the server. And these guys talk. Okay. Client and server, they talk, and usually it's a two-way. Oh, something. I saw the little pinwheel thing. I thought things were dying. So two-way communication. Let's say, whatever. Oh, do I have a? What's this guy? Oh, nailed it! Look at that. It's my little magic bar. Found a use. Put the arrows on the end. Very easily entertained. All right, so two-way communication. So the client makes requests to the server sends stuff back to the client, and this model is used all over the place in technology. All right, now we want to look at this specifically in the world of the web. All right, that's what's going to kind of apply to us as developers. So in the web, the client is our browser. All right, so Chrome, Safari, pick your poison. The server is our web server. Very interesting name, right? What kind of server do you have for the web? You have a web server, all right? Web servers, there's plenty of competitors out there, but there's really only two that matter. And it's potentially possible that that's an unfair statement because my knowledge of the different web servers is a little bit dated, but I feel this is pretty accurate. And at least it's good enough for this conversation. So we have two. We have Apache. And we have IIS, Internet Information Server. Apache, well, IIS is Windows. Apache is everybody else. Okay, so if you're running a Windows-based web server, you're running IIS. If you're running anything else, probably a Linux or a Unix-based web server, you're running Apache. Whatever. So it doesn't matter. Bottom line is that both of these dudes speak the same language. Okay, they're speaking the HTTP protocol. Okay, Hypertext Transport Protocol. That's what they speak. All right, which is just it's a domain-specific language that sends information back and forth between a web client browser and a web server. All right, so they can specifically ask for stuff. So these guys take in requests, HTTP requests from a browser, process those requests somehow, and spit the answer back out to the browser. And that answer is always in the format of HTML and JavaScript, because that's what web browsers know how to deal with, right? So no matter what the browser asks for, what it gets back is HTML and JavaScript so it can turn it into pretty pictures and stuff. Make sense? And you could throw CSS into there if you want, but you get the point. This is the food the browser eats. All right, and the web server is our blender. We send a request for our smoothie order, and it gives us our stuff, and ultimately gives us HTML and JavaScript. All right, now sometimes you might request a page like mypage.html. Other times it might be mypage.js. Other times it might be mypage.aspx, just as a few examples. All right. Now, this endpoint here is our file extension. And we have something known as, let's see if any of you know this first. So for instance, and this exists in other technologies as well. So if you have a file on your computer and it's a .docx, when you double click on it, what happens? What kind of file is that? A .docx file. So it's a Word, okay? Microsoft Word file, right? All right, so when you double click on it, Word opens. What's that called? What's that technology called that maps the .docx type to Microsoft Word? So .docx is known as a what kind of type? Anybody know the name of it? It's a MIME type. So MIME type is just a weird way of saying the extension on a file maps to a technology. Okay, .docx maps to Word. .jpg will map to some graphics program, that kind of stuff. All right, so in this case, the MIME type of these files coming in, when the browser requests mypage.html, that .html extension, the MIME type of that is called text/html. And it says, oh, I don't need to do anything special. All I have to do is go and find that file in my directory structure over here and hand it to you. Because it's a .html file, I can go ahead and rely on the fact that it already has HTML and JavaScript in it. It's good to go. It's a ready-to-eat meal. Make sense? All right, now, if we request a file like a PHP file, though, that has a different kind of MIME type. That guy's not necessarily ready. He's not done cooking. All right, so this guy's actually a program. The output of that program will ultimately be HTML and JavaScript. But when the web server gets the request from mypage.php, he'll look at the extension and say, this is a PHP file. Therefore, I need to go and grab the file from the directory structure. I need to hand it to the PHP module, okay? The special cook over here who knows how to handle PHP. So I throw it at him, he runs that program, and he hands me back the result, which is HTML and JavaScript. All right? And then he sends the result back over here to the browser because that's what the browser knows how to eat. If .aspx comes in, that's ASP.NET. That's the extension. ASP is active server pages. Call it Microsoft's competitor with PHP. It's fine. There's nothing wrong with it. So that's going to go to... it's actually not impossible to process that on Apache, but it's highly unlikely they would. So that would be on an IIS server. It would pass it to the .NET component architecture. It would run that program. It would then hand me back the HTML and JavaScript that I can then send over to the browser. Make sense? So no matter what happens, these requests come in, the web server does what's necessary to produce HTML and JavaScript out of that request. Make sense? That's how the client-server model works in web stuff. Now, we have two sides here. This is the client side, also called the front end. This guy is the server side, also called the back end. All right, so you'll often hear these two different sides referred to when you see internships and stuff like that, like, oh, we need a front-end developer, or we need a client-side developer, we need a back-end developer, or a server-side developer. So back-end or server-side people, they're writing software that lives over here. They would be the ones who write that PHP file, or who write that ASPX file. Okay, they write the programs whose output is HTML and JavaScript. The client side, or the front-end people, they're designing those screens. Okay, so they're working a lot in HTML, so they're making the things look a certain way. And then they also do some programming in JavaScript, because we do use JavaScript on the front end as well. Okay? Now, these guys aren't necessarily mutually exclusive. You can have front-end developers who are also back-end developers. You can have back-end developers who are also front-end developers. generally speaking, the front-end developers are the designers. Okay, they are the graphic artist folk who have some programming experience, who know how to make things look good and dabble in programming. They know enough to do what they need to do on the front end. And they make requests to the back end folks to make the logic work on that side. That's generally the way it works. All right. The back end people do all the logic to, make things happen behind the scenes, grab the latest sports scores, all that crap, and ultimately spit back out the result. Now, these two sides are actually getting a little bit mixed, and let me kind of tell you about that. So over here by this JavaScript that I have written in here, I'm going to say Ajax jQuery Angular and React. How many of you have heard of at least one of those? All right, 2.5 people. All right, which ones have you heard of? Okay, Angular and React, you know what those are?
I know JavaScript's frameworks, one of the many.
Okay. All right, I love that answer. Okay, because that's something that's often not understood. Okay, so I'm going to assume that most of the class missed it, so let's go with that I'll explain what you just said. What other technologies have you heard of?
jQuery.
jQuery, tell me what that is.
That's
It's a scripting language? Okay. Nobody's heard of Ajax? Okay, so she mentioned that she's heard of Angular and React. These are kind of our two current competitors. Angular is a Google technology. React is a Twitter, Facebook conglomerate thing. Okay, and she said they're JavaScript frameworks. All 4 of these are just JavaScript libraries. So even though at a glance we look at them, you got all these like names that float around, all these buzzwords. That it's impossible to keep track of them because every 5 minutes a new one's coming out. Almost every single one is like a rehash of something that already exists. So JavaScript in its early days was mostly used for like form validation, making sure you put in your username and password before we send that to the server, making sure you filled out the registration information before we tried to send it to the server, because it makes sense. Don't send a bunch of blank information for the server, waste the server's time processing it, only for the server to scream back saying, hey, you didn't give me everything I needed. Okay, because the server's processing potentially millions of people's requests, and your web browser is only dealing with you. So since this stuff runs on the client side, it's running on your web browser, we can handle a lot of that stuff before it ever gets sent to the server. That seems good, right? But some of the weaknesses in early web applications were, for example, if you're following sports scores, so many of you in here might be like cricket fans, right? Okay, is the World Championships coming up soon? Who's in it? Do we have the teams yet? Who's good? Who's good this year? India? Who? So India's not good. But not this year. All right. Okay, so you got your cricket. Okay, and you're checking the website because you want to know when the updated score is, right? Okay, and you want that score to update in real time, right? You don't want to have to keep hitting the refresh button over and over and over again to see the updated score. Okay, in the early days, that's how it worked. You had to keep hitting refresh because the new score, the updated score, is what came from the server telling you what to put on the screen right now. So that's where we started having some technology, starting with a technology like Ajax, which allowed a certain portion of the screen to make requests back to the server, and only that one little portion would update. All right, so what would happen is it was still updating, it was still hitting the server, but your entire page didn't have to refresh. Because there's some aspects of a web page that are static, they don't change, and then there's some parts of a web page that are not static at all, right? So Ajax was a stab at that. jQuery, let's call it the upgrade to Ajax. So jQuery said, well, you know what? Ajax is kind of a headache to use. So because what it's doing is JavaScript has access to this thing called the document object. And the document object is where the entire HTML document lives. And Ajax rewrites portions of that document object to only change part of the screen. But getting to that part of that document object is very cryptic. So jQuery gave a way for us to more concisely talk about a very specific portion of the screen. So it was a better way of rewriting that document object. That's what jQuery is. It's trying to solve the same problem. Make part of the screen update. Make sense? Angular and React, this takes it to the next level. Not only are we going to allow part of the screen to update when we tell it to, now we have something called two-way binding, where the front end here can make a request to the back end and say, I need an updated value. But at the same time, the back end can now talk to the front end and say, update your value. So this is kind of like the old pull email versus push email. Okay, do you hit refresh your email to hit the server and grab new email, or does the server push new email to your email client? Does that make sense? So two-way binding allows both sides to communicate with each other. When this dude has new information, he can push it here, and this guy automatically updates. That's actually a good thing, because that means that this guy here, the front end, doesn't have to have some sort of timer where every half second I'm going to check. Got new information, got new information, got new information. And since cricket takes a week and a half to play, then you're not going to have another score anytime soon, right? It's a made up sport. I need a cricket tutorial at some point.
Let's play cricket one day. Let's play cricket one day.
Let's play cricket one. I'm totally down. I want to learn about cricket. What was I talking about? Okay, so does this make sense, the JavaScript stuff? And part of the, me going through that is this idea that, especially as an IT professional, you're going to see all these buzzwords floating around. And those buzzwords very likely mean simple things. Okay, but it's really hard to fish through all of it. All right?
So what's the easier framework to learn? Because going into the JavaScript world right now is like a lot of confusion. There's tons of frameworks out there. So how do you decide?
Well, that's a loaded question. I've never worked with React. Whenever I do any I don't like web stuff personally, but when I do use web stuff now, I use Angular a lot. So I like Angular quite a bit because it's similar. We're going to be talking about design patterns sometime today. This similar to this idea called a model view controller. So it's having your design and your interface live in two different places. So we can have this variable sitting here and get updated by my code here and not have so much fluff over on this side. It's probably a kind of a crappy way of describing it without spending a whole bunch of time going in more detail, but I really like the Angular approach. These guys here would be considered older technologies, but not necessarily antiquated, because Angular, because of that two-way binding, really is solving a more evolved problem than jQuery is. So jQuery is still used plenty. So I would say that if you are dealing with a website that just needs to update some section of it at some sort of cadence, jQuery is easy to work with. Angular, I can tell you, is pretty easy to work with. It's quite possible React is better. I haven't used it, so I don't know. But there's 50 other JavaScript frameworks that do some of the similar things, some different things. So, really you want to kind of look at what are the kind of the go-to problems that a web developer needs to solve often, and what's the go-to move for solving those problems today. So over the last couple of years, Angular has been very popular, A, because it's from Google, and B, this idea of two-way binding, it has been a very popular problem to solve with all these HTML5 based websites and mobile apps. So that's been something that needed to be solved, and Angular was a decent solution for that. But every week somebody comes up with some new kind of problem that needs to be solved. And the punchline here is that these 4 that I picked are all solving effectively the identical problem. They're just evolutions of each other. But they're all just libraries of JavaScript or frameworks of JavaScript. So these aren't new languages. All these guys are doing is they're taking JavaScript, or somebody took JavaScript and they wrote some complex stuff, complex applications using JavaScript that does these things. So as long as you have JavaScript, you can do this stuff. But in order to do this stuff easily, you need to get this library too so that you don't have to reinvent the wheel, right? So that's what these are. And there's a whole bunch of other JavaScript frameworks that are the same way. You know, there's developers from all over the world, whether it's big companies or individuals, who write their own framework using this single core language that allows you to do things on that client side that's makes life easier.
Is there any relation to Node.js?
There is. That's going to be our punchline in about 10 minutes probably. I would say a strong relationship. You know, the .js thing should really give it away, but it's actually an important thing. So let's start talking about that actually. Okay, so when we talk about our web languages, I'm gonna list them on here. So we're gonna say Perl, PHP, Ruby, Python, and then Node.js. So Perl predated the internet. Okay, so Perl was a Unix scripting language that was when we had our very early web pages that had web forms that you needed to put in a couple of pieces of information, hit submit. They needed to be processed by some program. A program needed to exist that would take in your username and password and authenticate you or whatever. Okay, and the technology that existed back then was this technology called CGI, Common Gateway Interface. And CGI programs could be written in C, C++, but a very popular one for processing these things was Perl. Okay, and Perl was just a popular scripting language that a lot of IT professionals who were the webmasters in the early days, right? I mean, they were the ones running the Unix servers, and then all of a sudden their boss came in and said, "Hey, by the way, the internet's a thing. We need you to install a web server because we're supposed to have one." It's like, okay, so I'll install a web server. And now all of a sudden, like, hey, we need to have web pages on that web server. So now you're like, well, okay, well, what do I need to do? Well, we need you to be able to let people log into the site. Well, I only know one scripting language, and that's Perl, so that's what I'm going to use to make it work. So it's kind of, whatever tools you had laying around to do that stuff. But clearly, since Perl predated the internet, this was not a tool designed for the internet, right? That's where PHP came out. So we're going to say that this guy predated the internet. PHP, we're going to say, was the first, and this is a weak truth, but let's just say it's the first, was the first language specifically designed for the internet. Internet. All right, first language specifically designed for the internet. Now, why did we need that? Well, when you look at the types of problems, if we made a list of problems that you need to solve as a Unix system administrator, and you compare it to the types of problems you need to solve as a web person, a web programmer, those are a very different list of problems. And generally speaking, the web list of problems is a smaller list as well, okay? But it is a different list. So it would make sense to have a language that has a whole bunch of built-in libraries that already has solved a lot of the common web stuff, connecting to a database, that kind of stuff. All right. So PHP was a language designed with the web in mind. It had a whole bunch of libraries already written for doing web types of things. All right. So made life easier for web programmers, but it had a weakness. Let's just put weaknesses underneath here. So weakness is it did not support MVC. So let's talk about what MVC is. Nailed it. Design patterns. Anybody heard of that phrase before, design patterns? Was it in the videos? It was in the videos? Okay, what are they? Just roughly. It was a pretty easy definition, right? Patterns of that's a weak answer. Okay, so this was a proposed good solution to, quote, common problems. So an issue here is that what does good mean and what does common mean, right? You know, if you're working for Lockheed Martin designing missiles, you know, missile tracking systems is might be a common problem in your day-to-day life, where for most of us, that's not on our radar, right? Our common problems are more like, how do you make French toast? You know, that kind of thing. So, you know, same thing. We could have a design pattern for making a peanut butter and jelly. You know, sometimes you put, you know, you might, and what's good? What's a good way of making a peanut butter and jelly? You know, some people toast the toast, some people don't. Some people put the peanut butter on first and then put the jelly on top of that. Some people put it in separate pieces of bread. There's different approaches, and who's to say one's better or worse than the next, right? As long as at the end you have a bunch of stuff jammed between bread that you can shove down your gullet, right? Sometimes I just skip the bread and just scoop in the... You don't notice after about the first 3 or 4 bites. It's all the same. Super good. And then you got the peanut butter with it all mixed. Have you seen that? That's the peanut butter and jelly all in one bucket. Swirl. I think it's called peanut butter swirl or something. Oh, that's the stuff. Just get in there with a spoon. He knows what I'm talking about. All right, so design patterns in general is this type of thing, which effectively means that we can have an infinite number of design patterns because we can just come up with common problems, right? But every now and then, some design patterns float to the top, and the one that is interesting to us right now is this thing called MVC. This stands for Model View Controller. Was that in the video? Okay. Are you lying? It's like, man, I really missed that last question pretty hard. Let's just tell them none of this stuff is in the video from this point forward. Okay. Model View Controller. This guy says it's a good idea to separate our code. Well, let's put it this way. Our logic from our interface from our data. That's what it means in the big scheme of things. Now, let's talk about what that means in terms of PHP back here. As websites started getting more and more complex, a PHP program, when I say it did not support MVC, it's a file that was .php contained HTML, JavaScript, and PHP code, all mixed together. All right. Now, if you had a relatively small website, that's not the end of the world, right? If you need to go in and make a little update to the PHP logic, no big deal. You go in there, you find the 2 or 3 lines you need to change, you change them. But as these sites got bigger and bigger and bigger and more complex, you open up that PHP file and it looks like a war zone, right? You know, you just got lines all over the place, and you got carriage, just stuff is everywhere. It's just a mess. Because the HTML and JavaScript, that's our interface. That's what makes things look a certain way. Okay, that's the pretty side of things. The PHP code, that's the logic. Okay, remember, that's the guy that web server, that web server, when he got that MIME type for PHP, he passed it over to the PHP module, who ran that program and ultimately produced output that was HTML and JavaScript. And that's what got handed back to the client. Okay? Well, the programmer who wrote all this put it all inside of one bucket. All right? And now when you have to update that, you're having to fish through all this interface crap to get to your actual logic. When those two really have nothing to do with each other, because this is the way things look. And this is this is the stuff I want you to show on the screen, and this is how I want you to show it. That's what we're really saying, okay? So MVC says, it's a good idea to put those in a couple of different places, because as your site gets more complex, you'd rather have this one file that has all your pretty interface crap in it, And you'd rather have this other file that has all your logic crap in it, and then connect those two to each other in some sort of interesting way so that they are still linked, but not editable together. Make sense? Okay, and we even left out the third guide, the data. So, we have this thing called the model. So the model is like your database stuff. Let's not get too hung up on it right now. Okay, that just makes your code even worse, right? Okay, as things get more complex, now you get more stuff you're stuffing into that single file. Okay, bad news. So PHP didn't support MVC. Because when PHP came out, we didn't necessarily think about how how complex our websites might get. Ruby. And how many of you have heard of Ruby before?
The same thing as Ruby on Rails.
Yeah, good. So you never hear them just talk about the language Ruby. You hear them say Ruby on Rails. What does on Rails mean? Or is it just fun to say? Ruby seems boring. Ruby on Rails? And then you got the cool kids. They're like, I'm a Rails developer. They just leave the Ruby part off. That's what's supposed to be impressive, right? I'm really into Rails this month. I'm just doing a lot of work with Rails. So another weakness of PHP, besides not supporting MVC, is took time, nailed it, to set up the dev environment. Okay, and what I mean by that is you had to get a web server installed. You had to get the PHP module installed in that web server. So you had to have a whole web server up and running that knew how to execute a PHP file before you could even test your PHP code. Who's going to run it otherwise? Now, life is a little bit easier today. It's actually one of the reasons why PHP is still around. Is now, if you're going to write a website and you want to use PHP, you go to GoDaddy.com, you give them $5 a month, and they say, hey, here's a web server. PHP already works on it. Go. No time at all. You just you upload your file there. You also have to have some networking knowledge. You have to be able to run FTP and transfer files from your local machine to the web server and put it in the right place, and then know how to connect to it up here and all this stuff. But punchline is you can have your environment set up in a matter of minutes now, rather than before where you had to, might take a while to get it set up and tested and make sure it was working. So that made it difficult for programmers who are often different people than the IT professionals, right? You're this programmer. I sit around and write code all day, but I don't want to mess with bringing servers up. That's somebody else's expertise. Okay, so now this person is now reliant on somebody else to even start that development process. Now, at the end of the day, as a developer, you might do everything local here in your machine, you get everything working, blah, blah, blah. And then when you're done, now you have to deploy that to somewhere out there so the rest of the world can use it. Then you might need to bring an IT professional in to help you do that final deploy. Not the end of the world, because you were able to start development right away. So PHP had these couple of weaknesses that over the years have been remedied, and we'll talk about that, through third-party folks. Okay? Now, Ruby on Rails. Rails is actually a web server. Came with its own built-in environment. So this is Ruby so Ruby is the language. Rails is the web server. So a Ruby on Rails developer could just download Ruby on Rails and start developing right away on their local machine, and it all just worked. You could run your application immediately, and when you were done, then you could deploy it to something, a professional web server that also had the Ruby on Rails plugin on it. Not only did it have that, it had MVC built in. So Ruby, you had to do it the Ruby way. And with Ruby, there's a very specific directory structure you had to follow. So you had to kind of learn the Ruby way where, I put all my views here, I put all my controllers here, I put all my models here, and as long as I kind of stage everything in the right place and I refer to them in the right way, it just works. It's kind of like magic. And Ruby's still pretty popular today because you can build pretty impressive websites. Once you learn the Ruby kind of the neighborhood, if you will, you can build pretty complex websites pretty quickly with Ruby. Still popular today. But we're going to say the weakness of Ruby is that there was a learning curve to kind of getting to know the the environment to where to put stuff. You were also locked into their implementation of MVC. Their implementation of, with MVC, that's where do you put the views, where do you put the models, and specifically, how are those guys actually processed? Does that make sense? So Ruby comes with MVC. You're stuck with their implementation, whether it's good, bad, or whatever. You don't have a choice. So, it's like if you're going to the store and buying soda, you got 10 different choices for soda. If you're going to be a Ruby developer, your choice is Rails. Go. Now, it just so happens that Rails is pretty good. So that's not really a bad choice. All right. So it's, it's kind of like if you are a soda drinker, I know you always have those weird folks that they'll drink Coke but not Pepsi, or the other way around. But Pepsi and Coke, they're both pretty good, right? If you drink cola, they're both quality colas. They've been around for a couple of weeks and have kind of figured out how to get people addicted to their stuff. Same thing, Mountain Dew, Mellow Yellow. Some people like one better than the other. Mountain Dew is more popular, but they're fine. They're the same. I buy what's on sale. Except Mellow Yellow Zero is really hard to find. And I hardly ever have that because I only drink the diet stuff. I probably like Mellow Yellow Zero better than I like Diet Mountain Dew. Because the Mellow Yellow Zero has a Splenda in it instead of, aspartame or something? I don't know. All of it's going to kill you. Okay. So you're stuck with, so I'm going to write these a little bit different here. So I'm going to say Python on Flask. It's going to be that one. And I'm going to rewrite Node.js to be JavaScript on Node. So with this, Python is a language. Flask is the web server. But Flask is a third-party product. As the Python developer, I chose Flask as my web server. That doesn't mean that if somebody comes out with something better that I can't switch over to that and use them as a web server. Okay. I also then get to use my own implementation of MVC. So some popular implementations of MVC. Why is it escaping me right now? Jade. Last I worked with Python, Jade was kind of a popular MVC implementation. Again, third party. So somebody who just focused on MVC came up with a Python plugin called Jade. So Python has a package management thing. So that's really something else Ruby on Rails brought to the table. They have this thing called Gem, which is a package manager for Ruby plugins, let's say. Makes it easy to add stuff to your Ruby application where PHP didn't have this. Python has something called pip. Package manager, same thing. Okay, but you would just say pip install Jade, and now you have Jade. Pip install Flask, and now you have Flask. And then you can also say pip update, I think, and it'll update those if there's any new versions. And so it's package manager stuff. It's good. Makes life easier. So really, what did Python on Flask, or what did Python bring to the table? It separated those technologies while still giving you that ecosystem that had those technologies to choose from. So I don't, it's not fair to say Python is better than Ruby on Rails. Like I said, Ruby on Rails is still used often today, but effectively what we've done is we've you very, very, very rarely find anybody writing code in Ruby. They're always working in the Rails environment. Okay, those guys are kind of inseparable, where plenty of people, especially today, write code specifically in Python. There's a whole world of stuff today called data science. It used to be called big data. It's kind of a fun thing for people to put on their job applications and stuff like that. But it has to do with taking large amounts of data and kind of pulling meaning out of it. And Python's one of the popular languages for that. Another language that's popular for it is a language called R, which is a Java-based language. They just happen to be languages that have some libraries that lend themselves to those kind of things. But the punchline is that not everybody who's writing Python is writing it for web applications. It's a choice. So we've separated the language from some of the tools that allow you to do certain things. Okay? Now, this last one is kind of our, let's call it our relative new kid. He's really popular these days, Node.js. And this goes back to this screen right here where we talked about client side and server side. And one of the things we talked about here is that client side folks or front end folks typically are writing stuff in HTML and JavaScript. Server side folks are writing stuff in PHP or in Ruby or in Python, some other languages too, but stuff like that. Okay, they're speaking different languages. And if this person over here wants to kind of, dabble on this side, especially when they're not necessarily full-time developers, that's not their thing. A lot of them are designers, things like that. You want there to be a path of least resistance to allow them to do some of the server-side stuff, because a lot of times the server-side stuff is not overly complicated. You could have complicated server-side stuff, but there are plenty of things that you don't need to be a genius to do on the server side. But you do need to be able to work in the languages. So I like writing this guy as JavaScript on Node. So JavaScript is the language. Node is the web server. Okay. Actually, the real web server is called Express, but just roll with this for right now. So if Java, and these are all, so PHP, Ruby, Python, Node.js, these are all back-end technologies that ultimately spit out HTML and JavaScript. So if your front-end people already know JavaScript, wouldn't it be kind of smart to have your back-end technology also be written in JavaScript, a language they're already familiar with? Makes some sense, right? All right, so with that in mind, Node.js has become pretty popular. Now, Node.js also has one other kind of big thing they brought to the table, and this is called event handling. This is sort of related to that two-way binding thing we talked about with the Angular, where if something updates here, it notifies this guy. If something updates here, it notifies this guy. Event handling says, here's my server side of this. That ultimately, so a really powerful approach is Node with Angular. So here's my server side here. This guy might have different events that occur. We might plug in to sports scores. And when this sports score updates, it's going to come here. And then this guy is going to update your Angular site here. Okay, but instead of having to write a server on this side that constantly checks, is there a new sports score? Is there a new sports score? Is there a new sports score? This guy can just he can link to an event on this that will automatically push that back. So you could almost think of it like Angular on the server side to some extent. All right. Now the details of these things aren't overly important for us, but just a recognition of kind of how we got to our languages that we have today. Makes some sense? All right, so hopefully this kind of demystifies some of the buzzwords that are floating around out there. Every one of these guys is still used today, even Perl, but I don't think anybody's processing web forms anymore with Perl. But Perl is still a popular Unix scripting language for system administrators. But all these other back-end languages are still used today. It ultimately comes down to what's the right tool for the job. PHP, which was falling out of vogue for a while and was really the reason why some of these other guys popped up, has now become kind of like the Python world, because with PHP, now you don't have to have your own environment, because there's plenty of ways, there's plenty of third-party solutions where you can just have a PHP environment set up on your own computer in 5 minutes. These are just tools that are available out there. So somebody has solved that problem. Plenty of other people have come out with third-party solutions for some of the other PHP problems. I think there's a couple of PHP package managers now, so there's been some third-party things there. So with all this in mind, PHP's kind of had a rebirth in that a language has been very popular for a very long time that a lot of people know, that's still a pretty good language, has now had a bunch of friends come to the party to allow you to not necessarily run over to the dark side because your life isn't as easy anymore. One more thing I'll throw down here is in Node.js, we have a package manager called NPM, Node Package Manager. All right, questions about any of that stuff? All right, so let's take about a 10-minute break, and we're going to come back and we're going to talk about the Swift punchline, and then we're going to talk about variables. And I'll go ahead and upload this video.